This is Unit 10, and we're going to start out Unit 10 by graphing absolute functions. We have done absolute function or absolute values before, where you have the absolute value of 3, or which is 3, or the absolute value of -3, which is also 3. So the absolute value is a number's distance from the origin or from 0. It is always a positive number. So when you're taking out the number, it's coming out of the fences with it's positive. So that's why the absolute value of 3 is 3, and the absolute value of -3 is also 3. Okay. A function, you have done functions for a while, and a function is a relationship, which is a set of ordered pairs, which means it has an x and a y value, where each x value is paired with only one y value. In other words, there are no repeating x's. So x's can't repeat. You can do that by mapping, by graphs, by tables, and you should be able to recognize whether something is a function or not. Vertex of an absolute value graph, it's the common point shared by both halves of the graph, and it's shaped like the letter V. So absolute value graphs look like this, or they look like this. Those are the only two things that an absolute value graph will look like. Transformation. You learned transformations earlier. Transformations include rotation, reflection, dilation, and translation. And so it changes the position of a shape, curve, or line on a coordinate plane. We are going to emphasize translation, which means it moves. We are talking move up, move down, move left, move right. A reflection has a type of, it has symmetry, and that means that half of a shape, curve, or mirror image is the other half. So you've had butterflies, you've had other things that there is a line of symmetry. Okay, so we are going to graph some things. And so when we graph y equals x, it is a positive graph and a line, and it is also known as parent linear function, or linear parent function. If we graph, we're going to graph now the absolute value. So if I put a -3 in for x, I get the absolute value of -3, which spits out a 3. The absolute value of -2 spits out a 2. Input the absolute value of -1, output is 1. Input 0, 0, 1 becomes 1, 2 becomes 2, and 3 becomes 3 when you have absolute values. Absolute values do not change positive values. If I actually graph this, I have here where I have 1, 1, 2, 2, 3, 3, 4, 4, etc. But when I go on the other side, I have -3 is 3, -2 became 2, -1 became 1, and there is your V. And there's your line of symmetry. And your line of symmetry, you have also a vertex, and a vertex, remember, is the common point shared by both halves. So if this is your line of symmetry, the one that is part of both halves is 0, 0. The conclusion is this side from parent of y equals x, the left side flips up, and the vertex is a minimum point. So a minimum is the lowest point. So that one has a minimum. This one has a maximum because it has a highest point. As far as the parent function, all parent functions in all of math go through origin. So this function goes through the origin. This function goes through the origin. You'll be introduced later in the year to another parent function. It's called the quadratic parent function. That also goes through the origin. And that is page 1 of 10-1.